Hi everyone, welcome to another video on ISTQB Test Automation Engineer Certification. In this video, we will have an overview of various approaches for automating test cases. We will also discuss what steps are needed to successfully convert manual test cases into automated test cases. The discussion covers Chapter 3, Section 3.2.2 of the official ISTQB Advanced Level Syllabus of Test Automation Engineer Certification under the main section of Introduction to Test Automation Architecture Design. The test automation require a professional and practical step-by-step approach in which we put test plans into action, where we turn written test instructions into steps that a computer can follow to test the software automatically. In the test automation process, we have to usually take the following steps. The first one is that the test cases are required to be translated into sequence of actions, which can be executed against the software under test. Let's say we have a test case that checks if a login page is working correctly. The test case might include steps like enter username, enter password, and click on the login button. Translating this into a sequence of actions for the software under test means creating a script that automates these steps, sending the username, sending the password to the login page, and clicking the login button, just like a user would. Secondly, the documentation is really important as well. So this means writing down the steps of the test case in a document similar to a recipe. Each step is clearly outlined, including what actions to take and what results to expect. For example, a test procedure might say step 1, enter username, followed by step 2, enter password, and then step 3, click on the login button. In simple terms, documenting the sequence of actions is like writing down a recipe, while implementing it in a test automation script is like programming a robot to follow that recipe automatically. Both methods achieve the same goal of executing the test case, but in different ways. Test data is really important as well. So for any automated testing, we require some kind of test data. Let's consider the example of testing a payment processing system like an online shopping checkout process. In this scenario, defining test data for automated test cases could involve specifying various payment methods, for example, credit card, PayPal, bank transfer, along with corresponding test credit card numbers, account details, and expected transaction outcomes. For instance, let's say test data for a credit card transaction might include the card number, expiration date, CVV or security code number, and the expected result, whether it is a successful payment or it is an unsuccessful payment. And test data for a PayPal transaction might include the PayPal account, email, password, and the expected outcome. By defining this test data, we ensure that our automated tests cover different payment scenarios and can accurately simulate real-world interactions with the payment processing system. Once that is done, we actually have to verify, as we have already said that after processing the transaction, we verify whether it is successful or unsuccessful. So verification steps are like double checking your work to ensure everything is correct. In the context of automated testing, these steps confirm that the system under test behaves as expected after performing a particular action. Let's take the same example in our online shopping checkout example. After simulating a payment transaction, the verification step would involve checking the if the payment was processed successfully. This could include validating that the payment confirmation message appears, the order status has been updated, and the appropriate amount is deducted from the user's account. Let's now check options, their features, and supported approaches. which a TAE can adopt to automate test cases. The first one is the test automation engineer implement test cases directly into the script. It's the least recommended option due to lack of abstraction and increased maintenance load. The capture playback approach is suitable for this option. This approach involves recording user interactions and playing them back during testing. Those of us who have used Selenium IDE in the past know that it works on that approach, in which interactions are recorded and later on played back to repeat the test. The second option is the test automation engineer design test procedures and then transform them to scripts manually by writing code for each test case. So test procedures are designed first and then transformed into test scripts. It provides abstraction but lacks automation in script generation. Structured scripting approach, data-driven approach, and keyword-driven approach are suitable for this option. Test procedures designed using Microsoft Excel or Google Sheet, then manually translating them into test scripts, maybe using Selenium WebDriver, Puppeteer, or any other test framework, can be categorized as this option. The third one is the test automation engineer uses a tool to translate the test procedures into test scripts. It combines abstraction with automated test script generation. The approaches which are supported are structured scripting approach, data-driven approach, and keyword-driven approach. You can notice that the same approaches are supported by option 2 as well. So just as an example, those of us who have used Catalan Studio or Test Complete, where test cases are designed using a graphical user interface, then automatically translated into executable test script, that can be categorized as an example of this. The fourth option is that the test automation engineer uses a tool to generate test procedures, and scripts are generated from those generated procedures. It involves the highest degree of automation, where test scripts are generated directly from models using specialized tools. It also offers maximum automation, reducing manual effort and ensuring consistency. Model-based testing, including the process-driven approach, is suitable for this option. The difference between option number 2 and option number 3 lies in the degree of automation. In option number 2, test procedures are manually transformed into test scripts, while in option number 3, specialized tools automate this translation process, reducing manual effort and potentially increasing efficiency. Let's now go through which approaches are mentioned in the syllabus. There are 7 approaches in total, and these are capture playback approach, linear scripting approach, structured scripting approach, data-driven testing, keyword-driven testing, process-driven scripting, and model-based scripting. Each approach has its own advantages and challenges, impacting factors like adaptability, maintainability, and complexity. Understanding these automation approaches is essential for test automation engineers to make informed decisions based on project requirements and constraints. We will discuss all these approaches in detail, and in the next video, the first 2 approaches, capture playback and linear scripting, will be discussed. Thanks for watching. Please like, subscribe, share, and see you in the next video.